In today's course, we are discussing the concept of wind load and the importance of wind load in the aluminium industry. Let's start off by defining wind load. Firstly, wind load is measured in the units of pascals. Where else do we see these units? Well, if you go to your local garage, petrol station, and you pump up your car tires, that gauge is calibrated in pascals, or typically kilopascals. So pascals is effectively a measure of pressure. Wind load is therefore the pressure exerted against your window or door or shop front due to the wind. Now, the best way to understand wind load is to consider the following simple drawing. If I take a basic cross-section through a window, let's say this represents the outside of the window, and this represents the inside of the window, what I need to do is I need to consider a parcel of air. Let's assume that parcel of air is 1 meter by 1 meter by 1 meter, and that parcel of air is traveling at a certain speed and it is impacting against our window. It is that force which is important in our calculations, and therefore we need to define the wind load. Now, the problem with wind load, it is not related only to the speed of the wind, but it is also related to a few other properties of this parcel of air. It is a function of the humidity of the air. So in other words, the number of water molecules that are contained in this parcel of air. It is also a function of the temperature of this parcel of air. And it is a function of the density or the pressure of this parcel of air. So the greater the pressure, the more air molecules there are contained in this parcel of air, and therefore the more force that this parcel of air will exert against our window when it collides with the window. Now, we cannot simply talk about the speed of the air, because that does not define the humidity, the temperature, and the pressure. And in fact, to get the effective force against this window, we need to know the airspeed, the humidity of that parcel of air, the temperature, and the pressure. And the way we quantify this is by calling this the wind load of that particular situation. Now, why is this important? Well, the main reason why it's important is the National Building Regulations specifies the limit of the deflection of this aluminium profile. It considers that this aluminium profile is only supported at that point and at that point. And the National Building Regulations limits the maximum amount that that profile may deflect due to the effect of the wind blowing against that window. Now, if we draw this window from the front, we'll see something like this. Here I've got a window. That window contains a mullion. That mullion is only supported at that point and that point, i.e. those 2 points are fixed where it attaches to the outer frame. And the National Building Regulations is concerned about the amount that this profile can move in the center of that profile. The limit which the National Building Regulation sets is that this profile may not deflect or bend by more than the length of that profile divided by 175. In other words, if we imagine this is a window which has a mullion which is 1,750 millimeters long, the maximum that this profile may move will be the length of that profile, which is 1750, divided by 175, which equals 10 millimeters in this case. In other words, if I have a window which is about 1800 high and my mullion is 1750 long, the maximum amount that this profile may deflect is 1750 divided by 175, which equals 10 millimeters. Now that 10 millimeters is not a big deflection. So we need to say to ourselves, why are we limiting the deflection to a maximum of the length divided by 175? First thing to consider is, do we think the aluminium would break if we exceeded that? Well, definitely not. If you took a piece of aluminium about that long and you moved the center point by 10 millimeters, it definitely wouldn't break. It wouldn't even deform to the point where it will not bounce back to its original shape. So it's not there to protect the aluminium. Do we then consider maybe that it is the glass? Maybe we're worried about the glass breaking. Well, if I took a piece of glass which was the one edge was 1750 long and I've moved its center point by a distance of 10 millimeters, that piece of glass would most definitely also not break. So why then are we limiting the amount that that mullion may deflect when it's not a function of the aluminium is going to be bent or deformed, and it's not a function of the glass going to break? Well, the actual reason for this is something a little bit different. If you take a typical outer frame profile, and I'm drawing it simplistically, it would look something like that. I would then have a piece of glass which sits in that position there. Now, when you are designing an aluminium extrusion system, you have to ensure that there is a certain overlap, this distance here, between the edge of the glass and the glazing lip or the upstand. And that is to ensure that that piece of glass cannot come out of the frame. What happens when this profile starts deflecting is that if this is my piece of glass and this is my aluminium frame, as that profile deflects, that overlap, this distance here between the edge of the glass and the end of that lip, starts decreasing. And in fact, this limit of 1/175th, or the 1/175th of the length of that profile, is to ensure that you do not get to the point where that piece of glass can actually come out of the frame. Because at the end of the day, if I've got a window 3 or 4 stories up in a building, and that window fails and it falls out, the glass is going to do the damage more than the aluminium at the bottom. Alright, so that is the reason why we limit it to 1/175. Let's look again quickly at that outer frame and say, why are we only considering the mullion in this situation? There's my elevation view, and a very important criteria in this industry is you as an aluminium manufacturer are allowed to assume that as long as you fix your frame correctly to the structure around your frame, you're allowed to assume that that structure you are attaching to is strong enough to support the wind load. In other words, I'm going to assume that all the way around this frame it is attached to either the brickwork or a concrete beam or a lintel or whatever the case is. And as long as I fix my frame sufficiently onto the brickwork or the concrete lintel, I'm allowed to assume that that brickwork is strong enough to support the wind load on that frame. So I'm not concerned about the frame, and in fact you don't need to build any structural strength into your framing in general. As long as you adhere to the regulations of how and where to attach your frame to the brickwork or the surrounding structure, your aluminium frame does not have to carry any structural load of this window. It is only this element here, which is fixed at those 2 points, that is subject to movement. Now, this does not only apply for mullions, it would apply for an interlock, it would apply to a meeting style, it would apply to the 2 door styles on, say, a Vistafold where they come together. So any situation where I've got 2 profiles, a profile which is supported only at the 2 points, it has to comply with this regulation. So the exact same would apply. If I take a similar frame, and I assume my frame is fixed all the way around to the brickwork, so I don't need any structural strength on my frame, and I now have a transom in that frame. That transom is only fixed at that point and at that point. And that transom too needs to comply with this maximum deflection of the length of that profile divided by 175. So it doesn't matter if the profile is running vertically or the profile is running horizontally, you have to ensure that that profile is not going to deflect by more than the length divided by 175. Now this introductory level of wind load, we're not going to go in and look at the maths behind how this calculation works, but in a future lesson, on the advanced side of wind load, we will take this further and we'll explain how this calculation works. Now, that is the reason why wind load is even taken into consideration. Now we need to answer the question, how do we determine the wind load on a particular project? Well, first and foremost, you as a manufacturer are not allowed to specify the wind load on a job. And in fact, the only person who is qualified to specify the wind load is a structural engineer. Now, fortunately, on typically bigger buildings, particularly buildings which the fenestration or the windows are more than 10 meters above natural ground level, there will always be a structural engineer involved. But if you have a situation where you are asked to quote on a particular job and they do not specify what the wind load is, then you are going to have to assume a realistic value of wind load for that job. Now please be careful, you are not specifying the wind load, you are merely qualifying your tender. In other words, you are stating that this quote was done at a wind load of whatever it is. Now, typically in the South African market, we would work with the following ranges: 600 pascals, 1000 pascals, 1500 pascals, and 2000 pascals. The first thing to understand is that these are not the only potential wind load values. I can have wind load values anywhere in between these. So if an architect specifies a wind load on a particular job as 1200 pascals, don't tell them that they're a fool, because there is no such thing. There is. This is a scale that runs from 0 to whatever limit you want to hit. And in fact, if you go to do situations or installations in places like Mauritius, you might be required to work as high as 4,000 pascals. But typically in South Africa, this is the range of values that we would use to specify a job. Now, up until a few years ago, 600 pascals was allowed in the Gauteng region, or the Highveld, all right, due to the environmental conditions, and we will discuss those just now. But 600 pascals has now been reserved for internal applications only. So if you are in a shopping mall, and inside the shopping mall there's some shop fronts or some windows, and those windows or shop fronts are not on the external walls of that building, only then are you allowed to use the 600 pascal mark. Alright, for most other jobs you are going to specify or assume a value of 1,000, 1,500 or 2,000 pascals. And how do you make that assumption? Well, what we do is we need to understand the basic geography of South Africa so that we can understand which of these values or where to start on these values. So what I'm going to do is I'm going to draw a very crude map of Southern Africa. And really in South Africa we've got two predominant regions as far as wind load is concerned. We've got the central area of the country, which I'm going to mark as this red zone. Alright, and then we have a coastal belt, which I'm going to mark as that green zone. Now what you need to do is you need to identify whether the project you are doing is in the central region of the country or does it fall into that coastal belt. Now, what is the difference? In the central region of the country, generally speaking, we can say the temperatures are high. Think of the Karoo. Karoo is generally a lot warmer than our coastal region. Our air pressure, what can we say about our pressure? Our pressure is generally low. Why? Because this is high-lying area. If we take a cross-section of South Africa, it basically looks something like this. Okay, so we have obviously the coastal belts which are sitting at sea level, and then generally speaking, the center of the country is high-lying. So this red region in the middle here, because of the high altitude, in general, the air pressure is lower here than it is at the sea. All right. And then what can we say about humidity? Generally speaking, humidity is going to be low. Compare once again the Karoo to the east coast of Natal, for example, KZN. Okay. Obviously, we would have higher general humidity in our coastal belt than we will have in the center of the country. Now, in our coastal belt, the opposite is true. Generally speaking, our temperatures are lower than in the center of the country. Our pressure is higher, and our humidity is higher. Now, a high temperature, low pressure and low humidity all reduce the effect of that parcel of air striking against the window. Because if that parcel of air is warm, it is lighter than the surrounding air, and therefore it will have less impact against that window. If the pressure is low, it means there are fewer air molecules, and fewer air molecules colliding with our window will reduce the effect of that wind blowing against the window. And if the humidity is low, there are fewer water molecules in that parcel of air. So once again, it will have less impact against our window. Whereas in our coastal belt, lower temperature means cooler air. Cooler air, there are more air molecules or more dense air. So therefore, it has more effect of that air impacting against my window. I've got a higher pressure, which means that once again I've got more air molecules, which is going to increase the effect of that wind blowing against our window. And finally, higher humidity, more water molecules, more impact of that air against my window. So all the factors are in my favor in the center of the country, and all my factors are against me on the coastal belt of the country. So what does that help us? Well, let's go back to our typical ranges of wind load. We said we would typically work with 600 pascals, 1000 pascals, 1500 pascals, and 2000 pascals. Okay, we also said that 600 Pascal is reserved for internal. Now, if you are doing a job in the central region of the country where you're up on the escarpment, you generally are in warmer air, you have lower air pressure, and you generally have drier air, then, and that would have been our red region on the previous map, we would use a default wind load of 1000 pascals. So if you're based up in Gauteng or in the central region of the country, job by job, you would typically set your program's default to be 1000 pascals. If, however, you are based predominantly in the coastal belt, our green zone, then I would set my default wind load in the program to 1500 pascals. Now this starting point for inland and coastal includes pressure, temperature and humidity. It does not take into consideration the actual wind speed. Now that wind speed is going to be a function of the environment. Am I building a house in the middle of a cluster estate with a lot of houses around me which are going to block the wind? Or am I building a house right on the edge of a golf course where the prevailing winds are coming across the golf course or next to a lake or on the seashore? You have to assess whether you consider that site to be exposed from a wind point of view. In other words, if I'm working inland, but say I'm putting up a house in the middle of the Karoo, there's very few trees around, the land is flat, there's nothing to restrict that wind, then I need to move my specification from 1000 pascals, I need to up it to 1500 pascals. And the same thing applies in the coastal belt. If I'm working at the coastal belt in a relatively sheltered area, I can get away speccing 1500 pascals. But as soon as I go to an area that is exposed to the wind, maybe it's right up against the coast, the prevailing winds are coming over the sea, maybe I'm next to a lake, maybe I'm in a big open area, then once again I would need to increase that specification one level. So coastal, normally you work at 1500 pascals. If it's an exposed from a wind point of view, then you need to jump to 2000 pascals. Inland, your default would be 1000 pascals, and if you consider that to be exposed from a wind point of view, then you would increase your specification to 1500. So if you are asked to produce a quote and your client does not specify the wind load, obviously first prize is to say to the client, please can you tell me what wind load we need to design at? Alright, and if they are unable to do that, then what you do is you make an educated decision. You say, alright, it's internal, so I can work on 600 pascals, or I'm inland in a sheltered area, so I'll work on 1000 pascals, or inland in an exposed area from a wind point of view, I'll work on 1500 pascals, or alternatively, I'm working in the coastal region, so I would start at 1500 pascals if it was in a sheltered environment. If I was coastal and I was exposed from a wind point of view, I would specify 2000 pascals. Now, every single design that you do on StarFront requires you to specify the wind load, because that wind load is an important factor for determining the amounts that that profile will bend when it is exposed to that wind. You cannot simply just work on wind speed. If an architect says to you, the average wind speed in that area is 15 meters per second, that's not enough. You have to have the wind load, because the wind load takes into consideration the temperature, the pressure, the humidity, and the wind speed of that parcel event. I hope this has helped you a little bit to understand the very basics of wind load. We will have a lot more videos like this coming in the next few days, and we will build on this concept and we will explain some of the maths and some of the calculations that go in the background so that you have a better understanding of it. I thank you for taking your time to watch this video and look forward to seeing you at a future video from StarFront. Thank you.